All right, so you've probably seen these images floating around the internet for years, right? The ones with the bombshell claim that scientists have finally photographed the human soul. It's a huge, provocative idea for sure, but tonight we're going to dig in and find out what's really going on with this mysterious human glow.
So it all kicks off with these fascinating images of a human body that seems to be giving off this faint, almost otherworldly light. Now, these aren't just your standard snapshots. No, they were taken with some incredibly sensitive equipment, and they kicked off a huge global debate. So the big question we have to ask is, what are we actually looking at here?
Okay, first things first, let's get one thing straight. This is absolutely not a thermal image. You know, the kind of predator vision thing you see in movies. A thermal camera, like the one on the right, it just shows body heat, and that's usually hottest right in your core. But these other images, the ones on the left that we're talking about, the light is brightest around the face and head. We're looking at two totally different phenomena.
And here's where things get really interesting, where the mystery really kicks in. This faint glow, it only shows up in living things. The moment something dies, poof, it's gone. It just vanishes. You can see it right here. The difference between a living rat and a dead one is stark. And, you know, this is the exact observation that got people thinking. Could this be some kind of life force? Or could it even be the soul?
So, to get to the bottom of this, we've got to jump in the time machine. Because the hunt for this weird light didn't start in some fancy futuristic lab with people hooked up to machines. No, way. It all started about 100 years ago with an onion.
Back in 1923, there was this biologist, Alexander Gurwitch, and he noticed something strange. He saw that one onion root could actually make a nearby root grow faster, even when they weren't touching. So he came up with this idea he called mitogenetic radiation. Basically, that cells were talking to each other with invisible light. But here's the thing, nobody could prove it. Over 500 different scientists tried to replicate his experiment and just got a mess of mixed results. His theory was basically laughed out of the scientific community. He died with his work in limbo, but his daughter, Anna, she didn't give up. And in 1962, with a brand new, super sensitive piece of tech, she finally proved her father was right. Living cells do give off an extremely weak ultraviolet light.
And when I say faint, I mean it's almost impossible to imagine how faint this is. We're talking about maybe 1 to 1,000 photons, that's particles of light, per square centimeter per second. To put that in perspective, a regular 60-watt light bulb pumps out something like a quintillion photons in that same space and time. It's just a staggering difference. And that is why it took decades for anyone to nail this thing down and prove it was real.
So, okay, the light is real. Check. But that just opened up a brand new, massive question. What's it for? And right here, the scientific world basically split in two. Two different camps formed, each heading down a completely different road to find the answer. Let's start with Path A. This was the group of scientists who looked at this glow and thought, no way this is just some random accident of biology. They were convinced they were looking at evidence of something, well, something much bigger.
And the biggest voice in this camp by far was a guy named Fritz Albert Popp. Back in the 70s, he gave the light its name, biophotons. And he didn't just name it, he built this whole grand theory around it. He argued that these photons weren't just random flashes. They were coherent, organized, kind of like a tiny biological laser. He believed this was the body's main information highway, a sort of cellular radio system that directs everything from how we grow to how we heal.
Now, Popp's ideas were really captivating, and they inspired a lot of other people to push the boundaries even further, making some pretty sensational claims. You had Konstantin Korotkov, who said he'd built a device that could actually photograph a person's consciousness, or aura, as it left the body after death. And then there was Masaru Emoto, who became famous for claiming that our thoughts, positive or negative, could physically change the structure of water crystals. So yeah, that line between hard science and spirituality, it was getting really, really blurry.
All right, let's hit pause and rewind. Let's go back to that fork in the road and check out the other group, the skeptics. These are the scientists who heard all of Popp's theories about cellular radios and lasers and just said, whoa, hold on a minute. Isn't there a much simpler, chemical explanation for all this?
Their big counter theory was based on a process that's actually pretty well understood. It's called chemiluminescence. It's just a fancy word for light that's created by a chemical reaction. The best example? A firefly. That's all chemiluminescence. So they argued that this human glow wasn't some complex communication system. Nope, it was much more like the exhaust fumes coming out of your body's engine as it burns fuel.
So for decades, this debate just kept going. Mystical life force or boring old chemistry?
The biggest problem was that the light was just so incredibly weak, nobody could get a good look at it to study it properly. To finally crack this case, what science really needed was a new piece of technology, a huge leap forward that could finally let us see what was going on.
And they got it. It was called the cooled CCD camera, and it was an absolute game changer. They had to chill this thing down to minus 120 degrees Celsius just to get rid of all the background noise and distortion. It was so unbelievably sensitive that it could detect a single photon, one particle of light, and tell you exactly where and when it appeared. For the very first time, scientists could actually create a live, moving map of this human glow.
So, armed with this incredible new tool, a Japanese biophysicist named Dr. Masaki Kobayashi decided he was going to be the one to finally settle this thing, once and for all. He designed a series of really elegant experiments to find the smoking gun, the real undeniable source of this light.
So for his first big experiment, he pointed this new camera at a rat's brain, and using other sensors at the same time, he found a perfect one-to-one match. Anytime the brain's metabolic activity cranked up, when it started using more oxygen, the photon emissions spiked in that exact same spot. The light was directly tied to how hard the brain was working.
Well, this discovery pointed a giant flashing arrow at one prime suspect, something called reactive oxygen species, or ROS. You've probably heard of them by their more common name, free radicals. These are basically unstable molecules that are a totally natural byproduct when our cells make energy. And the more energy a cell turns out, the more of these free radicals it creates. So the question became, could this be the source of the glow?
To prove it, Kobayashi came up with another brilliant experiment. This time, he took a plant and stressed it out by infecting it with a virus. Just as he predicted, the plant started producing a ton more of these ROS molecules and began to glow much brighter. But then came the kicker. He introduced an antioxidant, the stuff in blueberries that's good for you, which is specifically designed to neutralize free radicals. And the result? It was incredible. The plant's glow dimmed by 50 to 80%. That was it. That was the final definitive proof they needed.
And just like that, case closed. The mysterious glow that had people talking about souls and life forces for decades was, in reality, the chemical signature of oxidative stress inside our cells. It's simply the light that's given off when these unstable free radical molecules react.
So, no, it's not the soul. And you might think, well, that's kind of a boring ending. But hang on, because the real twist in this story isn't about what the light isn't. It's about what it is, and how this boring truth is actually unlocking a mind-blowing new chapter in medicine.
I mean, this whole story is just a perfect example of the scientific process in action, isn't it? You start with Gurwitch and his initial observation that nobody could quite replicate. Then you get Pop's really compelling theories that just couldn't be verified. And finally, you land on Kobayashi's work, which was peer-reviewed, tested, and confirmed. Each step was about slowly but surely filtering out the speculation and replacing it with solid, hard evidence.
And the payoff for all that hard work? It's huge. Because now we know this glow is tied directly to cellular stress and free radicals, we can use it as a powerful diagnostic tool. Get this, cancer cells, because their metabolism is in overdrive, they glow up to 4.7 times brighter than healthy cells. That means we could potentially spot cancer before a tumor even has a chance to form. We can literally see and track inflammation, measure skin damage from UV rays, and even monitor our body's 24-hour clock, all by measuring this tiny, faint glow.
And that's really what's so incredible about this entire scientific journey. It's such a great reminder that the flashiest, most sensational story, it isn't always the true one, but the real, evidence-backed truth, even if it seems a little less exciting at first, often turns out to be way more profound. And in this case, it could literally be a lifesaver.
When you boil it all down, this 100-year-old mystery wasn't solved in a philosophy class. It was solved by building a better camera. And that just makes you wonder, doesn't it? What other huge, profound mysteries of our time are just waiting in the dark for a piece of technology that's sensitive enough to finally turn on the lights?